Okay, so we're looking at gas stoichiometry. So remember, stoichiometry is when we start with one chemical and we convert to a different chemical. What's cool about gas stoich is what this paragraph says right here. So it says that our coefficients not only represent a mole ratio, but it also represents a gas or a volume ratio. And that comes from our Avogadro's principle, where if they have the same volume, they have the same number of moles. So we could say that 13 to 8 represents the moles of O2 to moles of CO2. Or we could say it's the liters of O2 to liters of CO2. So this has some effects on how we do our conversions. So let's look at the first one. Okay, it says at what volume of oxygen gas is needed to complete the combustion of 4 liters of propane. So they're giving us a volume, they're asking for a volume, so we can do a pretty short problem here. So it's going to look like this. So here we might be used to seeing moles over moles, but we can do liters instead. Okay, so my coefficient for C3H8 is 1. My coefficient for O2 is 5. So I put that into the calculator. 4.00 times 5 divided by 1 comes out to 20 liters of O2. Okay, our next one says when calcium carbonate is heated, carbon dioxide is released. What volume of CO2 at standard temperature and pressure? If 15.2 grams of calcium carbonate is heated. Okay, so they told us standard temperature and pressure, so we know at some point we can use the 1 mole equals 22.4 liters conversion that we learned in the Avogadro's principle video. So this is going to start kind of like a grams to grams conversion. So let's go ahead and annotate. We have this information circled, and then this information boxed in. Okay. So I got my number for my question. And again, it starts like a grams to grams problem. So we would have to convert like this. And I know that 1 mole of calcium carbonate weighs 100.086. So I got that from the periodic table. Here, we're going to do a mole to mole ratio. So I started with calcium carbonate. They're asking me about carbon dioxide. From our formula, it's just a 1-to-1. Our equation is just a 1-to-1 ratio. And then our last, in our new part here, is using this. So I have 1 mole of carbon dioxide, so I know that that is equal to 22.4 liters of carbon dioxide. Okay, all of that gets thrown into the calculator, and it comes out as 3.40 liters of carbon dioxide. Okay, let's do one more example. that you might see. Okay, so ammonia is synthesized from hydrogen and nitrogen. If 5 liters of nitrogen reacts completely by this reaction at a constant pressure and temperature, how many grams of ammonia are produced? So what are they asking for here? They're asking for grams of ammonia. Okay, and they're giving me a lot of information here. So they're not just giving me 5 liters. They're also giving me a pressure and a temperature. So this is not at our standard temperature and pressure, so we can't use this conversion. Instead, we're going to have to use the ideal gas law. So this is what it's going to look like. So a good clue that you're going to use the ideal gas law is that they give you a lot of different information. So they gave us a pressure, and it's already in atmosphere, so that's good. Our temperature is already in Kelvin. R is going to be this. Volume, they gave us as 5 liters. So we're finding number of moles. So once we find number of moles for the nitrogen, we can then use that information to find how many grams of ammonia. Okay, so let's plug this in. And I'll label this, so over here we're dealing with nitrogen. Okay, so 3 Okay, and that gets rearranged, and N equals oops, I labeled this wrong. So all this was for nitrogen. Okay, so now we have moles of N2. So we're going to need to find grams of ammonia. Okay, so okay, so our starting number. So we have moles of N2, we need moles of NH3. So it looks like for our ratio, it's a 1:3 ratio. And then our last one here, mole of NH3 to grams of NH3. Okay, and this one I don't, yeah, I do have it. Okay. Okay, so that is our final answer there. So those should cover examples for all the practice problems. Okay, this last problem was I used the wrong ratio. So this should be a 2. And our answer, let me recalculate it. Should be 20.9. Okay, sorry about that. Okay, bye.